Hey, how old are you?
5.
So what is learning?
I don't want to explain this.
Do you know what learning is?
Yes, but I don't want to explain it.
Can you give me an example of learning?
I don't know what that means. I don't want to do it.
All right.
I don't want to do this.
Go get your brother.
Why?
I just want to ask him.
Mommy wants you.
Now listen, you let Bubba answer, okay? Hey, Hubert.
Yes,
How old are you?
I am 11.
What is learning?
Ooh, that's a tough one to tackle. I personally would say that learning is the training of your mind to think in a certain way that will always work. However, sometimes you learn methods that only work in certain situations. But if you learn enough things, you can develop your own procedures to fix those problems for stuff that, for stuff that you were never taught.
Mommy.
Yeah, so it really just comes down to what you're trying to do.
So, how do you know if somebody has learned something?
A lot of people would say ask them some questions. And while that can be good in the short term for learning of facts and stuff, procedures and stuff that you have to do for that, it wouldn't do too well if you were asking, like, I can't come up with a good example.
It's okay. You're doing
Yeah.
great.
Holy, that's
Is there anything
so
else you'd like to
bad.
say about learning?
Not really. It's a tough one to tackle.
How do you learn?
I learned by watching someone do it a couple of times. Mostly just when the stages how I learn in is I see someone else do it, I attempt to do it myself, and I rewatch it a couple of times and try and analyze exactly what they're doing. And if I can pull that off with my own hands or my own body parts or whatever they're doing, and I can repeat it pretty reliably, I would say I've learned it. And with simple stuff like a new math concept, that's pretty easy to do.
You think so?
Mm-hmm.
How do you think your brain gets to that information? Like if you try to recall something that you've learned or try to do something you've learned, how does your brain go get that information?
Okay, so neurology warning. This is about to get really nerdy.
Uh-oh.
So the brain stores memories in the I don't remember part of the brain. And a certain memory is triggered by a certain neural pathway, and then another part of the brain recognizes that and sends information to your amygdala, visual cortex, if you're a visual thinker, stuff like that. And it really just depends what kind of memory it is. If it's the memory of, say, a loved one who passed away recently, it would send information to the amygdala, and the amygdala would produce sad chemicals. If it's a happy one, like, say, the first time say, the time you beat that time you beat that one really, really hard boss in a video game, the information would be sent to the amygdala and the prefrontal cortex for both of them, and the amygdala would produce happy chemicals. It just depends on what you were feeling at the time, and if you process it to see a little bit deeper into the memory, sometimes those emotions can change.
So what are some sad chemicals?
I don't really remember, but I do remember the happy chemicals.
What are the happy chemicals?
Serotonin, oxytocin. Oh, I forgot the last one.
Starts with a D?
Depression no longer in.
No. I think it's dopamine.
Oh yeah, dopamine, my bad.
Or is that the sleepy one? What's the sleepy one?
The sleepy one, I believe it's melatonin.
Oh. Hi, Emmy.
Hi.
Yes, so there's that.
So you think there's some some chemical processes
Yeah,
involved.
there's a lot of chemical involved.
Do you-
And
do
on
you-
the large scale, it's really hard to recognize.
Yeah?
Because if you take 2 or 3 neurons and they fire, like, you don't know what that means. But suddenly you get billions and trillions of them together. And then stuff like this happens.
Let me ask you this. So I feel like in the past, a lot of researchers have tried to use classical physics to explain learning and thinking and social behavior.
That's not going to work.
No?
Thing about classical physics is that it's too linear.
Oh.
Learning is not linear in any way. Now, if you think about it, cells are pretty dang small. Not small enough to exhibit most of the effects of quantum physics, but pretty small. So I feel like if you apply a little bit of the quantum physics, the quantum physics superpositions,
Yeah?
and combine that with some of the classical physics linearity, that could help a lot with explaining learning.
So you think there might be something in quantum physics there that can help us understand? I think your sister figured out how to make your
I don't know why I did
video
that.
game thing work.
Can you turn that off?
No, just let her play it. It's okay.
Okay, that thing's really loud.
It
though.
is super loud. Lauren, can you turn the volume down a bit?
It doesn't have a volume slider.
Yeah, it does.
In the middle.
No, it doesn't. It does not have a volume slider.
It's like all or none. It's binary.
Yep.
Oh.
It's a Boolean.
It's what?
It's a Boolean. Yes or no? Do you want to have all the volume? Yes or no?
Man.
So what do you think about quantum physics, or so far what we know about quantum physics can help us understand learning
Yeah.
or social behavior or
Mhm.
thinking?
We probably know more about the bottom of the ocean than we know about quantum physics in the universe.
You think so?
Yeah, well, we know more about the universe than the bottom of the ocean because it's really hard to get to those.
But what about relating quantum physics to learning and thinking?
That could work, and I've heard that a lot of people are trying to incorporate quantum physics into their fields, and I feel that would help because a linear view and a top-down procedure wouldn't work very well
Yeah.
because a lot of things aren't linear. They can go back and forth, skip through a couple of stages, not go through it at all.
Yeah.
It
Okay.
really just depends on who you are, what you're doing, and how you learn.
So context.
Yeah, the context. That matters a lot.
Your sister is really loud.
Yes,
Yeah,
yes,
let's
she
talk about
is.
Okay. Well, thank you. I have really
It's still
enjoyed
not
this
charging.
conversation with you, Hubert.
You're welcome.
Love you, babe.
Love you.